This is a DANL100 Programming for Data Analytics. Chapter 11 Simple String Manipulations. Agenda. In this short video, I'll discuss the following topics. Topic number one. How to generate a string variable by using double or single quotation marks as character to string, and how to test how many characters for a string variable. Topic number 2, substitution function, SUB and GSUB, GREP, logic OR and logic AND. Replace all the letters and replace all the numbers. Topic number 3, repeating indicators, dot, question mark, plus, and a star. Topic number 4, generate an R dataset for all the zip file at Professor French data library. Then write a loop to download them all. Topic number 1. So let's look at the basic. First, so let's generate some like a string. Okay, so x equals first, let's generate some like a string. Okay, a string variable, sometimes we call it characters variable. It's quoted, included with a pair of double quotation or single quotation. For example, x equals, this is a great job. Okay, so we can use is. So this is this character variable, string variable? The answer is choose. Okay, suppose we have 100, then it's false. Okay, present value equals 100. Okay, then is this present value then it's false. So it's not a character variable. Okay, and also we can use the single quotation, y equals hot. Okay, so y equals hot, so this is, and see characters y, the answer is truth. Okay, so we use double quotation marks or a pair of double quotation mark, a pair of single quotation mark to include a sentence or phrase inside a pair. Okay, so this is a characters variable. Okay, so another one is called n, a function called n, char. So this is how many characters long. Okay, so this is x. Okay, so what is x value? X value is simply, and we can manually count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So total we have 19 characters. Don't confuse with the number of the data point. For example, x equals this is great. And suppose we have x. Okay, so x, so if we use length x, we got 3 values. Okay, the first data point is this is great. Okay, so if we use number of charx, then we got 3 numbers. Okay, the first number 4, how many characters for the first data point? Okay, the second one is, the last one is 5 character long, is great. Okay, so this is nchar. Okay, and the next one is, I'm going to show you how to paste, put 2 strings together. I love y equals dogs. Okay, so we have x and y, X is a string, I love, and Y is a dogs. Okay, if we put them together, so we use paste, P-A-S-T-E. So paste X and Y. So paste, we paste them together. Suppose, so this is, we can call the Z. The Z value will be I love dogs. Okay, suppose I want to put something between. So again, there's absolute meaning here. I use SEP, S-E-P, it means separate. Suppose I put a comma here. Okay, so paste X, comma, Y, S-E-P, then we choose comma. And we can choose another characters. We can choose other characters. Okay, so if we don't want anything between, then we use double quotation, or single quotation. Okay, so obviously the default SEP, the default value is space. Okay, so actually we can, so these two are equivalent. So these two, we use separate SEP equals, and we include one space. So actually this is default value. Okay, so if we don't want put anything between, then we can use SEP equals double quotation, nothing between this double quotation. Okay, alternatively we can use paste 0. Okay, so paste 0, we put nothing here. Okay, so let's look at another one. So n equals 2010 to 2021. So this is what n value. Okay, we want paste year and n. Okay, so we paste year. Year is like scalar. Year is scalar, and is a vector. Okay, so obviously we don't want any blank between, so we can use paste and SEP equals double quotation. Okay, then nothing between years and the number. Year 2010, year 2011, year 2012. Alternatively, we can use paste 0. Okay, we use paste 0. Then we save some typing. Okay, so paste year and n, and remember this n here is a vector. Okay, then we can use sep equals double quotation, nothing between these two double quotation marks. Okay, alternatively we can use paste 0. Okay, so this is a function I use quite often. Okay, so this is paste, combine them together. So next one, I'm going to show you how to substitute. Okay, so let's use x equals, so a, b, c, d, e. Okay, a9, 9. Okay, so this is a simple string. Okay, simple string, we have numbers, and also we have the letters. Okay, suppose I want replace a with we want to replace letter A with number A. Okay, so this is, we can use sub substitute. Okay, number A with letter A. Okay, so A, and this is X. Okay, and you see the first A we replace with number A. Okay, however, you see we have another A. Okay, so this substitute only substitute once if we find a match. Okay, if we want to substitute all the A, then we use G. It's called global substitute. Okay. G is global. Okay, so you see that we have one A, we have another A, we replace these two A with letter A. Okay, we can also replace with some, so let's use a question mark. It's much easier to talk. So this is X. So X, we have A, B, C, D, E. Our intention is replace A with a question mark. Okay, because we have multiple we use global substitution. Okay, so let's talking about so-called logic OR. Okay, so logic OR. And you see we have the so that's X. Okay, so suppose we want to replace AB. Oh, let's use ABC. Okay, so we want to replace ABC with nothing. Okay, global substitution. So we use ABC. Okay, so this is okay. Okay, so ABC, single quotation with nothing, X. Okay, so this is X. Okay, and so this is the bracket, and what is called, square bracket, A or B or C with nothing. Okay, we replace A, we replace B, we replace C with nothing. Okay, and another shortcut is we can use A hyphen C. Okay, and also we can A hyphen Z. Okay, because and so this is X. These are all lowercase. Okay, I use A to Z, lowercase a to Z, lowercase z. Okay, so let's use X equals A, B, C, D. Then we use A, Z, okay, D, 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 and one, we have some number. We have A, B, C, D. Okay. Okay, so let's look at the result. Okay, and because we have a lowercase and we have capital letters, and you see the lowercase will be replaced and will be eliminated. However, the capital letter is still there. Okay, then obviously we can use A to Z. Okay, in this case, we remove all the lowercase letter and all capital letters. Okay, capital letters. Okay, so this is substitute and global substitute. Okay. Next, so let's look at the logic AND. Okay, so this is logic AND, and we use parentheses. Okay, and suppose we have X equals A, B, C, D, A, B, C, D, E, F, and we have some numbers. Okay. Before we said we are going to replace A or B with a question mark. Okay, we have A or B. Okay, now we can say, hey, we are going to replace AB. We treat AB as one unit. Okay, so X, so let's go to G, SUB, global substitution, substitute. So we use AB, and then with, suppose we use question mark as before with X. Okay, and before, remember, so let's look at the difference. Okay, so if we use this one, okay, so this is, we replace A with question mark, we replace B with question mark. Okay, so A is independent from B. Okay, however, for this one, AB, so we only replace, we treat AB as one unit. Okay, so let's modify X. So X equals A, B, C, D. Okay, A, B, C, D, E. We have extra A, 999. Okay, so we have AB. Okay, we have AB and we have A. Suppose we use this one, A or B. So 1 question mark, 2 question mark, 3, 4, and 5. Okay, then we expect 5 question mark because we have 3A, 1. So we have 3A, 1, 2, 3. We have 3A, we have 2B. So we have 5 question mark. Okay, and if we use OR, so if we use AND, then we only see 2 question mark. Okay, because this is first AB and this is second AB. Okay, so this is logic AND. So we have logic OR. Okay, so this is logic OR. Okay, we have the logic AND. Okay, logic AND. Okay, we use parentheses. Okay, so this is logic OR, this is logic AND. And so another one is logic NO. Okay, so this is NO. And so we use caret. Okay. Okay, so let's use that one. Suppose we x equals, we have some letters, and also we have the letter. Okay, we have some numbers. We have lowercase letters, we have A, B, C, we have numbers. Okay, suppose we want to replace all the letters or delete all the letters. Okay, so then we can use G, SUB, and then we use lowercase a to z, A to Z. Okay, so we use logic OR with nothing. So this is X. Okay, I repeat. Okay, suppose we want to remove all the letters, whether it's lowercase or capital ones. Okay, capital letters. Okay, then we use OR. So A, lowercase a to lowercase z, capital A to capital Z. Okay, so let's look at the effect of no. So actually, this is logical OR. Okay, so logical OR is different. It's just opposite. For this case, we only keep letters. Okay, we only keep the letters. Okay, and the first one we only we remove all the letters. We only keep letters. And okay, so let's look at another one. Is suppose we want to remove numbers, so we can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and also this is OR. Okay, and so this is from with 0, we move with 0, we move 1, we move 2 up to 9. Okay, alternatively we can simply use hyphen. Okay, so 0 to 9. Okay, 0 to 9. Okay, for this one, remove all the letters. And if we use OR, okay, so if we use OR, for this one, we remove all the letters. Sorry, we remove all the numbers. And the opposite is we keep all the numbers. Okay, and sometimes these are not equivalent. So let's look at the other. We have some x with some values. Okay, so let's type some x. Okay, x equals, and so we have letters, and also we have some plus, minus. We have some very other type. So let's look at okay, we have some different combination. We have the letters. We have plus, minus, less than, high, larger than, an exclamation mark, and equal signs. So let's look at the different one. Okay, and you see from here, suppose we remove all the letters, all the numbers, then we remove 1, 2, 3, 4. Okay, we keep something else. Then if we use logic no, then we only keep numbers. So this is one of much better way to retrieve numbers from a string. Let's look at another sign. Okay, suppose let's look at x equals year 2021, and we have something between we have another year 2021. Okay, so this is our string. So actually we have year 2021 and year 2021. Okay, suppose we want to replace year 2021 with year 2022. Okay, so next year, so we can use G sub and year 2021 with year 2022. Okay, so there's no ambiguity. Okay, because we have two same phrase. Okay, and then we use global substitute. Okay, however, suppose we want to replace the first one, we leave the second one, we don't replace the second one. Okay, then we use this so-called caret. Okay, so caret is this one at the beginning of the string. Okay, and so this is caret, and we replace it at the beginning of the string. Okay, so this is so-called at the beginning. Okay, so you see we only so this is our x value. Okay, we replace the first 2021 as 2022, then we don't touch the second one. Okay, the opposite is we use dollar sign. Okay, so if we use dollar signs at the end, so this is dollar sign. Okay, the dollar sign at end of phrase indicate this appear at end of the phrase. Okay, this we only replace year 2020, the second one, so we don't touch the first one. So caret at the beginning of a string and dollar signs at the end of a string. Next, I'm going to discuss a very important function. It's called the grep. Okay, so this is grep. Okay, so grep is used to identify a pattern exists or not. Okay, suppose we have in file, so we call the http data yyyy.com data r farmer french 3 monthly.rdata. Okay, so this is first one, and it's called in file. So let's use in file 2. Okay, and we have two R data set. Okay, we have two R data sets, so they are identical. So let's make it different. Okay, so we use daily. Okay, so in file and in file 2. Okay, so suppose we have two R data set. Okay, the first one is located remotely. Okay, because we use http data yy.com. Okay, so this is monthly, and the second one in file suppose is located locally. Okay, we know, so this is, if we define this way, so this ff3 daily.rdata we are under our current working directory. Okay, because if we use for this one, okay, for the locally we use load in file 2. Okay, because this is local. Okay, for the remote we use load URL in file. Okay, so let's assign a value called a, and so actually it's okay. So my point is, suppose we have two files, two our data set. One is we locate remotely. We have to apply two functions. Okay, so one is called load URL. If it's sit on our computer, we only apply one. Okay, and because this is grep, we can design a function. Okay, we design a function and apply it to both. Okay, so basic idea is I'm going to show you. Okay, so this is grep http. Okay, so http, so in file. Okay, and so this is, we can treat it as true. Okay, 1 represents true, and in file 2 is 0, so this is false. Okay, suppose we use this a, length a, so length is 1. Okay, and suppose we make it 2, the length is 0. Okay, then we can design a function. I'm going to launch a notepad to show you the logic. Okay. Okay, so this is let me see, make it bigger. So actually this logic, suppose we call the load 2. Okay, load 2. So this is function. Okay, in file. Okay, so this is in file, and eventually I'm going to type the logic, then I'll show you the code. Okay, so if a equals 1, okay, I'm going to okay, and so this is function, and we test whether this pattern exists or not. Okay, so if a equals 1, else okay, so this is a structure of our data. Okay, so this is, we use load URL in file. Okay, and I'm going to show you my complete code. Okay, okay, so this is our function. Okay, we input the in file and we test it. Okay, we test whether this pattern exists or not. If this pattern exists, we apply load URL in file. Else, we just load. We use load. We don't use URL function. Okay. So this is the structure of this load. Okay. So let's look at the my function. Okay. So my function will be, I use load. Okay. And so actually the true will be dot load underscore. Okay. So this is the key. Okay. And name, actually in file is better. Okay, so this is function called name, and first one I test whether this http ://twice and whether it exists or not. Okay, if it exists, then we assign a value, okay, to b. Okay, then we return get b. Okay, so this is key, is get function. Okay, otherwise we apply the function only once. Okay, so let's save. Let's just generate something. Okay, x equal 1 to 1000. So let's attend. So let's save. So let's save and .x. So let's call it ff3 daily. Okay. Again, so this is not the true Farmer French daily. I just want to show the whether it works or not. Okay. Okay. So the first one is called in file. This one. Okay. So let's call a equals load in file. Okay. So this, let's look at a. Okay. So this is a little bit different from previous a equals load URL, because that one will only show the name of the underlying. So let's use A2. Okay, so let's use A2. So we use load URL in file. Okay. So A2 only contain the variable name. So variable. So we have to use head.x. .x actually is true dataset contain the useful information. Okay, so if we use .load it will assign the value to A. So this is a different, okay. So dot, okay. My point is whether it is the remote and another one is in file 2. So this is local. And so we can use b dot load in file 2. Okay. We know this is from 1 to 1000. Okay. I repeat the concept here. Okay. So we can design a function. We can design function by using this grep to test whether pattern exists or not. If the pattern exists, we apply load URL. If it's not, we apply to load. Okay, of course. So let's go back to .od .load underscore, and also we load, we assign this one to a B, we return get B. So actually this one we get the underlying data set. Okay, it is also true we use return get B. Okay, so actually these two we can put down here. We join these two as one line. Okay, so this is about application of grep function to test existence of a pattern.
Shutterstock Music.
Topic number 3, some repeating indicator. Okay, and the first one is dot. Okay, dot, question mark, plus, and star, and exactly repeat 5 times. Okay, so the first one is dot, and dot represent any character. Okay, so question mark is about 0 and 1 time, plus is 1, 2, 3 up to many times, and star is can treat as combination of these two. Okay, start. Okay, so let's look at one example. So x equals, okay, x equals, so we have some blanks. Okay, 4, and suppose, so this is x value. Okay, and suppose we want to remove all the blanks. Okay, we have no clue how many blanks, and so this is sometimes we call leading blank, sometimes this is called trailing blank. Okay, and suppose we want to replace, okay, g sub, okay, so this is blank, okay, blank start, okay, then with nothing, okay, x, okay, so this is a blank, so we replace blank and with 0, with 1, with 2, with many. Okay, I think we can use plus as well. Okay, so this is plus. Yeah, we have the same result. Okay, for this one we remove the blanks. Okay, so if we want to remove the leading blanks, okay, so we can use this one. Okay, and so this is leading blanks, so blanks with 1 blanks, with 2 blanks, with many blanks. Okay, so if we want to remove the ending blanks, then trailing blanks, then we can use dollar signs. Okay, so again, so let's look at question mark. Okay, so 1 and 2, so plus 1, 2, 3 up to many. Okay, star including the combination of these two. Okay, so let's look at the usage of this one. Suppose we have x equals ha 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 ha. You see, ha 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 ha. Okay, then we have some numbers. Okay, so if you can see, so ha 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 ha, we have 2 ha ha. You have 1, 2, 3, 4, 5. Okay, suppose we want substitute ha ha exactly 5 times. Okay, so this is exactly 5 times with a question mark. Okay, so this is X. Okay, so haha should be what is called ha, H and ha. So this is okay. If you see the haha, the first one we only have 2. HA repeat twice. Okay, so this is HA repeat 5 times. Okay, suppose we want to do something with this one, then we can specify. So this is the first one, parenthesis, is a logic end. Okay, so logic end repeat 5 times. Okay, logic end repeat 5 times. Okay, so this is our pattern. Then we replace with a question mark. Okay, I'm going to apply this one to one special case. Okay, remember I introduced so-called N letter. So this is called N letter. So this is called N letter function. Okay, suppose I type 4. I'm going to show all the 4 letters function. Okay, suppose I type 5. Then we see all the five characters long function. Okay, we know mean is 4 letters. Okay, 4. So let's see. So MEAN here. Okay, so how to generate this function? So actually I use the Preface. So this is a Preface. Okay, and so this is dot exactly 5. Okay, so exactly 5. However, we have seen many. Okay, so actually I use before and end. Okay, so actually this one will be exactly 5 again. Dot represent any characters. Okay, any numbers, any letters, any signs. Okay, curly bracket 5, curly bracket. Then I use caret represent at beginning and use $sign at the end. So this one will indicate exactly 5 characters long. Okay, so if you calculate this one, 1, 2, 3, 4, 5, then we have exact 5 characters long. Okay, suppose I use 15 or nothing, so we use 10 character long. Wow, we have so many. Okay, we have so many. Okay, so this is a simple application of dot, question mark, plus, and star. Okay, and if you're interested in this topic, string manipulation, so next topic will be text analysis, TEXT. Text analysis is quite popular. Okay, text analysis is very good topic to do research and to have some deep understanding of the string manipulations. Let's look at one real application. Okay, we're going to do like 2 tasks. Okay, the first one is we are going to generate our data set to list all the zip file from Professor French data library. The second step, and we download all the zip file. Okay, we are going to apply the text. It's not text analysis, it's called string manipulation. I repeat, we are going to do a simple exercise to use the string manipulation or text analysis, part of text analysis, to generate our data set, including all the zip file. Then we download like all the zip file. Okay, we are going to go to we are going trying to just type professor, just type French data library. Okay, as first step, and we can Google French data library. Okay, so this is Professor French data library. Okay, so this is Professor French data library. Okay, I'm going to record this link. Okay, I'm going to copy, and I open a notepad. Okay, I paste it here. Okay, later we are going to use this one. Okay, we are going to use this link. Okay, so this is the link we are going to use, and we can just manually download one. For example, this is Pharma French 3-factor monthly data. So suppose I just click here, then the data will be downloaded. Okay, so if I go to my download folder, so C user, and download, then you will see a zip file. Okay, so this is compressed zip file download. So F research data factor. If you double click, so this is factor we just downloaded. Okay, so let's go back to the Professor French data library. So if we right click, and we can see the view the page source. Okay, then we use Control F, and we use .zip. Then we use zip. Okay, then we can find so many zip file. Okay, zip file, and so let's copy this one. Okay, so let's copy the first one, and so this is. I'm trying to find out later. I'm going to find out. So actually, is we replace this. So I'm going to copy and paste. I'm trying to find correct location. Okay, so this is French. Okay. So hopefully this is a correct link. Okay, so I can just paste. Okay, so if it is correct link, later I'm going to use this one as my part of my code. Okay, so let's choose another one. And okay, it's server error. Okay, so let's go back. I think pages faculty, I should add FTP. Okay, no. So FTP. Okay, just a summation of these two. Okay. Oh, sorry, I'll go back. Copy. Yeah, this is a correct one. Okay, so let's go back to R. I'm going to copy this line because this is web page. We are going to get our all information. Okay, so let's call it path. Oh, just web page. Suppose web page, and so this is our web page. Okay, so this is our. So this is our web page, http and beertuck.mouse. Okay, then we can use X read line. Okay, read line. So this is a web page. Sorry, it should be. Okay, it doesn't matter. It should be a web page. Okay. Okay, so this is a web page we got from the Professor French data library. Okay. So this is, we called, we can just type X. Okay, we have, okay, so how many line? So this is X. So we have 2522. Okay, remember I mentioned we can use so-called grep. Okay, so this function will tell us existence of specific pattern because we are interested in the zip file. Okay, so we use a grep dot zip. Okay, dot zip from X. Okay, and so let's type X. Okay, so we see we have like over 600. Okay, so length A. Okay, we have 622 zip file. Okay, or potential zip file, or with .zip. Okay, so let's look at the several ones. So let's look at so this is X from 532 to, so let's use to 600. Okay. Okay, so actually we can use X and head 8. Okay, so this is will show about 6. Okay, so let's see. You see the first one. So this is FTP and zip. This is first one. FTP, and this is text file, zip, CSV file, and next one is FTP, Farmer French Weekly, and the next one is FTP, is weekly TXT, weekly CSV, and daily TXT, and daily CSV. Okay, so obviously we can use XA to pick up all the lines, all the line with this one. So let's call B equals A, so X, A. Okay, when A is true, okay, dimension of B will be so 600, okay, LENG. So we have 622, okay. So this is our B data set. So let's look at the B, okay. Obviously, we don't want anything after zip, okay, after zip. Okay, so this is B. So let's call the B2, okay. We are going to G sub, okay, G sub, okay. We want zip. Anything after zip, remember dot star, okay, dot star, okay, and so let's use dot zip, okay. So we are going to replace dot zip. You see here, dot zip after that, okay. Okay, so let's use zip dot zip with zip, okay. I'll make it easy. So this is B. Okay, I'll explain the concept here, okay. So we want to replace zip plus everything after it with zip. Okay, so let's look at the B2, sorry, B2, okay. You see, we don't have anything after zip because zip, I use AND, so this is logic AND. So we don't treat the Z as independent. We treat the ZIP in the parentheses as one unit, because period represent any symbol, including letters. So if from here it's like backward slash, okay. So this one plus everything else, okay. So eventually we remove everything after zip. Okay, of course, we keep the zip, okay. Okay, so let's look at this one. Obviously, FTP, right? So FTP will be, so actually, if you really want to make it clean, because we have .zip redundant, because everything we are .zip. So let's use head B2. So let's use 50. Then you see everything will have the .zip, 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 and .zip, and we can remove this .zip, but I just want to make it easy to understand. I keep .zip. Okay, so let's look at how can we remove something. You see, FTP. So everything, the keywords will be FTP, right? So this is FTP. So basic structure is we want to remove anything before FTP. Okay, so B3 equals global substitution. Okay, and we use dot start. Okay, dot start. Then we use FTP. Okay, so this is identical. This is identical to the .zip, .star, because zip and in parentheses. Okay, I'm going to type. Okay, so let's finish this one first, and we use FTP. Okay, we place with Okay, we place this with FTP, and so this is B2. Okay, I'm trying to explain the concept here. Okay. Oh, I forgot star. Okay, this is star. It's not A. Okay, so this is anything before FTP. So anything, any string before FTP, we place it as with FTP. Okay, then we apply this is strings B2. Okay, so let's look at the B3. Okay, so this is so let's use 50. Okay, and now we have very clean data set. Okay, you see here FTP and zip, and so this is last one FTP. As I mentioned, if I want to save it, if we want to save as a permanent or long-term data set, usually we don't need FTP / and we don't need .zip, because in the future when we're trying to download the data, then we can add these two parts. Okay, usually I use .x, so I use .x, and I save it. I call the .x p3, sorry, b3, and I save it .x and file and c temp. So actually I can save under my current working directory. So this is farmer French list rdata. Okay, I remove .x, remove b3. Okay, so if I load ff list and h.x tail.x, and that's it. So this is task number 1. So task number 1 is simply generate an R data set with all the zip file from Professor French data library. Okay, and so this is .x. We have 622. Okay, 622. Okay, so let's see how can we download the zip file. Okay, we are going to use this line. Okay, so this is download. So this is in file. So this is out file. Okay, this is from web binary, and so this is method. Okay, so we are going to use this one. Okay, and obviously now our data set is .x. Okay, so let's just assume I equals 1. So this is .1. Okay, so let's look at the structure of A. Okay, so this is I equals 1. So this is .x is our just generate our data set, including 622 zip file. Okay, so let's go back here. And so what is A? So A is FTP, and ffresearch.zip. So this one, okay, so let's go back here. And so this is obviously we need, so let's call it path. Okay, path equals, so this is, so this one, okay, and obviously we need add a / and close it. Okay, so this is our path. Okay, so this is path, and in file will be paste 0 path and A. Okay, I'm going to make it a little bit smaller. Okay, we can see it clearer. Okay, I'm going to, yeah, to move them down. Okay, so let's look at here. So this is our path. Okay, our path, and we combine them together. So let's look at the in file. Okay, so this is our in file. Okay, our path. I have to. Okay, so let's copy and paste. Okay, so this is our in file. Okay, so in file. Actually, I just show you. We can simply just manually download it. Okay, manually download it. And let's use another one. I can paste and FTP. Okay, sorry, I have. So this is not correct. So this is not correct. Okay, so it's up to Ken French. So this will be okay. Okay, the path in file. Okay. So let's compare with here. You see, previous one I show here. So this should be correct. Okay, so let's copy and paste. So in file. Okay, so this is our in file. We can just manually try. Okay, I'm going to use another one. I paste it here. Yes, I can download it on the left hand side. Okay, so this is correct input. Okay, so let's look at the output file. Okay, so obviously out file we don't want to use. We don't want the so-called FTP. Okay, so out file. So let's use G, or we can use sub. Okay, we want removed FTP. This one. Oh, it's nothing. Okay, so substitute. Okay, so this is right parentheses. Okay, so this is our correct output name. Okay, so this is our correct output name. Okay, then we can just simply call it out. So this is out file. Okay, so this is our out file sub. Oh, left right parentheses. Okay, out file. Okay, this is out file only contains the name. Okay, I'm going to copy and paste here. Okay, I repeat the several lines. Okay, and so we have a path. So we have a path. Then we have a list. .x is list with 622 zip file. Okay, if I equals 1 and we got A. Okay, then we put the path and A together. So this is our input file. So this is our input file. Okay, then we remove original beginning FTP /. So this is our output file. So input out file. Then we download it. Okay, so let's try to download it. Okay, you see, then we can use dir pattern pattern equals, so we use .zip. Okay. I have other zip file. Okay. Okay, I'm going to remove. Okay, so let's remove. I call the dd remove file remove dd. Okay, so let's do it again. Okay, so let's download. Okay, dir and pattern zip. We can only see one zip file. Okay, now we can write a loop. Okay, so this is our loop. Okay, I'm going to copy this one, and so usually this is my step-by-step approach. Okay, for this one, I still need this pass. Okay, I need a pass. Okay, so I called for I in 1, and so actually obviously we can calculate n dot x. Okay, we can n 1.n okay, as I mentioned, I use I equals 1 to test it. Now I can just copy paste to run it. Okay, so usually I just try. So let's run the n first. So n will be 622. Okay, so let's go back. Usually I use a small data set. Okay, so this I from 1 to 10, and I don't need this one. So a equals, so let's run it. So this is about to download the 10 zip file. Okay, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1 is on top, and we have 10. Okay, so usually after so let's type dir pattern equals zip. We still have 1. Down. Oh, this is always 1. Sorry, so we have to use I. Okay, and so let's do it again. Okay, obviously we see the different size. Okay, so let's look at dir. Then we have 10. So this is 9, we have 10. Okay, the last is we can use quiet, QUIET equals true. Okay, and the default is quiet is false. Okay, quiet is true, then we are not going to see this command. So let's try it, and so enter. Okay, so see how many from the previous error message. We know I equals 11. We have an issue, then we can simply ignore 11. Okay, so this is, so let's start from 12. Okay, so let's look at another one is I equals 12. Okay, I equals 12. So let's use 13. So 11, 12. So we have issue 11 and 12. Okay. Okay, so let's look at I equals 37. So 37. So I'm going to here 11, 12, 37. So 37. Okay, then we use 38. 38, 39. I think a better solution is we test existence of a remote data set, and if it does exist, we download it. Otherwise, we print some message, then we go to the next one. Okay, I'm going to stop here. So basic idea is we have two tasks. Okay, the first task, we generate our data set to list all the zip file contained with the Famba French data library. Okay, then we write a loop. Then we contain this loop. Then we download all the zip data set. And so let's look at the dir pattern. Okay, pattern equal zip. Okay, obviously we download the 53 and we download the 54 zip data set.
Shutterstock Music.